This question says that we need to find the measure of all of the angles. So hopefully you remember that all the angles in a triangle add to 180. So first I'm going to solve for x by solving each of these angles adding up to 180 degrees, and then I have to plug them all back in to solve for each angle. When you do that, you get that x is equal to 21, but remember they want you to find all of the angles. So you have to plug 21 into each one of these to find out the angles, and I'll do that for you real quickly. So when I did that, I got 96 for the big angle, the smallest one is 21, and the top angle is 63. If they ask for the type of triangle, you should call this an obtuse, because one angle is more than 90, and it is scalene because all the angles are different. So to find number 7, they're asking us to find the area of the shaded region. So we need to find the area of the big shape. And in our case, that's a rectangle, which is base times height, and that would be 8 times 5. So the whole thing is 40. But remember, we have to take away the part on the inside. We don't want this part. And that's a triangle. And remember, a triangle is base times height divided by 2. So you have to do 3 times 4, which is 12. Divide by 2 is 6. So you have to subtract those two. And 40 take away 6 is 34 for the final answer. So in question number 8, they gave us angle 1 and angle 2, and I wrote them in. And hopefully you notice that they are both vertical, so they're equal. So to solve, I'm going to set them equal to each other and then solve for x. And when you solve for x, you get 115 over 5, which is 23. And then they want to know what angle 2 is. So we just have to take 23 and substitute it back in. So I'm going to do 2 times 23 and then add 95 back. And then you get 141 for this angle right here. And angle 1 would be the same amount. Question 9 says, use the quadrilateral work to answer the questions below. It says the diagram is not drawn to scale, so it's not drawn the way it's supposed to look. So they give us some numbers right here, and this was a question similar to one on your last test. They say fill in the chart with the appropriate values to make a parallelogram and then make a rectangle. So the first thing to notice, I think, well, and actually they have a couple and then they want a square. I'm going to go with a rectangle first. So if they tell me that this is a 4 and it's a rectangle because they said C is 4, then D would also have to be 4 and B would have to be 4 if it's a rectangle, because remember a rectangle looks like this where all these segments are the same, and A would have to be 4. So pretty much all of those would have to be 4. Now, they then give us another part, and they now want a square. So they said if D was 2, well again, if you have a square, and if one little part is 2, then they're all 2. So that means that A and B and C, all of these, would have to be 2. And then the last part says that they want it to be a parallelogram, which looks something like this, but not look like a rectangle or a square. So if you notice, one is longer than the other, but they bisect each other. So they told us A was 3. Well, if A is 3, B has to be 3. And if it's not a rectangle, the other two are different. And they said we could use any of these numbers that we want. So you could use 2 and 2 or 5 and 5. I like 5 and 5. You could use whichever ones you want. In question number 10, there's something that's very important, and that's this first part of the question. They tell you that PQ and PR are the same length, which makes this an isosceles triangle. And hopefully you know that if it's isosceles and two sides are equal, the two base angles are equal. So this is 35. Now what they want us to find is angle P. Well, all the angles in a triangle add to 180, so I'm just going to subtract the 35 and the other 35, and when you do, you get 110. So angle P is 110 degrees, even though it doesn't look like it. In number 11, they ask us to solve for x and y in the triangle. Now, if you notice, when they put this segment equal to this segment and the same on the other side, these two, this is called the mid-segment theorem. And the mid-segment theorem is that if you have the two midpoints like this, and they're connected, this line segment will be parallel to the bottom and twice as long. And if they're parallel, then I know if this is 82 degrees, then this angle also is 82 because they're corresponding. And if I want to find y, all I have to do is 180 minus 64 and minus 82. So I'm going to solve that for you real quickly. And I solve that, I get that y is 34 degrees. Where it says explanation, I'm going to write corresponding because the corresponding angles were equal. And I also know that the angles in a triangle are 180 degrees together. So I actually have two reasons for that. Now the last part is they want us to solve for x. And you can't just set this segment equal to this because it's not. The top segment, you need two of them. So 2x plus 3 plus 2x plus 3 has to equal 42. Because the length of the top, you need two of them to equal the bottom. So I'm going to solve for x real quickly. So I solved for x and I found it was 36 over 4, which is 9. And the main reason is because this segment is half of the bottom, or you need to double the middle to get the base. So that's why I wrote two of them. You could do half of the bottom. If you wanted to solve 2x plus 3 equal to half of 42, which is 21, you'll still get 9. In number 12, they tell us that line P and Q are parallel. That's important. And we have transversal T. And I'm looking at these two angles, and part here they want to know the relationship. And the relationship is they're called same side. Well, this is their name. Same side interior. And their relationship is that they are supplementary and they add to 180. So I'm going to go ahead and solve 6x minus 25 plus x plus 30 equals 180. So when I solved for x, I got that x was 25. And then the last part of the question says find the acute angle. So what I'm going to do is I'm going to plug it into both and just figure out which one's acute. So I'm going to plug it into that one. 25 plus 30 is 55. And if I plug it into the top one, I get 6 times 25, which is 150. Take away 25 is 125. So the acute measurement would be 55. In the last question here, they're telling us some information. First, they told us that it's a parallelogram, so that's important because that means opposite sides are parallel. And in the end, they want us to prove triangle ABC is the same, congruent to CDA. So we're going to fill in some information. Line 1, where it says given, I'm going to put that ABCD is a parallelogram. Hopefully you have more space than me. And that's the given piece of information. Part 2 says that they're parallel, and I'm going to go ahead and mark BC is parallel to AD, and AB is parallel to DC or CD. And the reason why is definition of a parallelogram, because a parallelogram has opposite sides that are parallel. So that's the definition of parallelogram. The next part says angle BCA. So that's this angle right here is congruent to DAC. That's this one. And hopefully you recognize those angles. Those are called alternate interior angles, and they are equal to each other. The next part says that we have another alternate interior, and I hope that you can see this one. It's kind of like an upside down N. This angle and this angle would be equal. So I'm just going to fill in the names of those. That's angle BAC. That would be equal to angle DCA. Line 5 says the reflexive property, which hopefully you recognize that they share that side. So that's when AC is equal to AC. And you could put a congruent, you can reverse the letters A and C if you want to. And then the last question is, why are they congruent? And I hope that you see that they have this angle, this side, and this angle in both triangles. This angle, this side, this angle. So by ASA, we know that they're congruent. And the last part is just to double check. It said label the diagram, and we did that, and we filled in the missing reasons.